Hey, welcome to graphing trig functions. And before we start graphing trig functions, I'm just going to review the procedure for graphing any function. So like if we have some sort of function, how do we get a picture out of this? Well, typically what we do is we try to figure out in a table of values a bunch of points, right? We just plug them in. So whatever x is, like typically we plugged in things like this. And then we figure out what the y values are. And then we go, hey, these are just points that we can now put into our picture. And we plot these points. We go, hey, we got a graph. Okay? So that's the procedure of drawing a graph of any function. So I'm going to use that same approach now to trig functions. So I'm going to clear off the screen. I'm going to paste in my ready-made grid. And now I'm going to put down what my trig function is. My first one that I'm going to try to get a picture of is y equals sine of x. So I need a bunch of points in a table of values. So let's do that. We'll build our table here, get a bunch of points, and then we can draw a picture. So what sort of points should I plug in there? Well, if I was new to this and I had no idea, I would just go with the same sort of points that we've done in the past. 0, 1, 2, 3, something like that. Okay. And then I'd go to my calculator and I would just figure out, well, what is the sign of 0? And I go, oh, it's 0. So, hey, that's a point on my graph. I wonder what the sign of 1 is. Now, make sure, by the way, that you are in radians. Okay. All of this now is done in radians. So make sure when you're looking up things like the sign of 1, it's the sign of 1 radian. Well, I did this ahead of time. I got 0.84. And then the sign of 2, I got 0.91. The sign of 3 is 0.14. I mean, all this is I'm just plugging it into the calculator, getting a table of values, and then I can draw my graph. Now, let me show you roughly what this graph would look like. It's an interesting thing, but you'll notice that none of these y values is ever greater than 1. So it's kind of like you have a maximum of 1 and a minimum, if I kept going here, of -1. And you would plug in points all the way up to about 6. So 1, 2, 3, 4, 5, 6, and a bit. So we'll say that's 7 here. So let's plot in some of these points and show you roughly what the graph looks like. Let's see here. At roughly 1.5 is where the thing we think reaches its maximum. And then just over 3, just beyond 3, is where it returns to 0. So we kind of get this curved shape like this. Whoops, that wasn't too good. Let's try that again. Okay, something like that. And if I kept going, just going to fill in a few things here. There would be our lowest point sort of around there. Yeah, if I graphed, enough of these points, this is kind of what the graph would look like, and it would keep going. There's no reason it would stop. And the truth is, I could have plugged in some negative points as well. So this is your basic sine graph. Now, you'll notice I struggled a little bit figuring out where these points were, and that's because these choices for x are actually not the most practical. There are certain key points, and I'm going to let's get rid of this table of values here, which actually is not a very good table of values. Okay, I show you that because that's sort of where we would normally start. But here's the better table of values, and this really only comes from experience. If you did this enough, you plotted it enough times, and you went, hey, you know where these key points are? Like, obviously 0 was a good point. 0, 0 starting off our graph. But the next key point was this maximum. Wouldn't it be nice to know exactly where we hit 1? And it turns out this is pi by 2 is where it hits. a maximum of 1. And this point here, which was just a little bit bigger than 3, was actually pi, and that's where we return to 0. So you got this point here, then it goes to its maximum, and then at pi it returns to 0. And then, hey, halfway between here, this is 3 pi by 2, or it's like saying 1.5 pi's. We hit the minimum of -1, and you probably know what this point here is. That is 2 pi. We return back to 0. So these, because they hit kind of these maximums and minimums, these are really important key points, and I would memorize them. If you know that, every quarter of the way through your graph, you're getting to your next key point, it makes it so much easier to draw these graphs. Okay? So that's your basic sine graph and the key points to help graph it. Let me show you what cosine looks like, and instead of going through all of the trouble of building up a not so good table of values, I'm going to go right into the graph, and I'm going to mark the key points along the way. So again, for cosine, so we'll just label this. This is the cosine function. Cosine, actually let's even mark these key x values along here. So this is pi, and this is 2 pi, and then this is half of pi, and this is 1.5 pi's. All right, so those are kind of my key x points. With cosine, when you plug in 0, you actually get 1. And then when you plug in pi by 2, you get 0. When you plug in pi, you get -1. And when you plug in 1.5 pi's, you're back at 0. And if you plug in 2 pi, you return to your maximum of 1. So I'm going to try and draw this carefully. It actually has exactly the same shape as the sine graph. It's just kind of offset, kind of what's happening here. All right, so it kind of looks like that. And of course, this keeps going in both directions. But yeah, if you think about it, it's kind of like it's an offset sine graph. Sine, it's like you took your sine graph and you slid it, what did we do? We would have slid it a little bit to the left, kind of what this is. But it really has fundamentally the same shape as the sine graph. All right, that's those two. Now let's take one last look at one important graph, and that is the tangent graph. All right, so this is y equals tangent of x. Now it looks a little bit, well, actually it looks nothing like the other ones. So what are our key points? Again, pi by 2 and pi, and then 1.5 pi's and 2 pi's. Okay, now tangent, it doesn't have a maximum and minimum. What it does is, and if you plugged it in, you would see all these values, but it actually, as you approach pi by 2, you get, well, it starts at 0. Let me just say it starts at 0. And as you approach pi by 2, well, the graph numbers just keep getting bigger and bigger. So what you have is it goes roaring up, and there is a vertical asymptote. Now, as soon as you go slightly beyond this, and maybe it's easier to say at pi it's 0, but it goes down to that negative part here. So it's kind of like from 0 approaching pi by 2, it goes roaring up to infinity. Then as soon as you go beyond pi by 2, it's like it's crossed around the world or the universe, and here it comes back from negative infinity and comes roaring up back towards 0 at pi, and then the whole thing just repeats. So at 1.5 pi's, you're going to get the vertical asymptote again. So these happen recurringly, and then you get the same basic graph again. Okay, so you actually get 2 cycles of this graph if you go from 0 to 2 pi. Okay, but we'll talk more about that later. The only really important key points for tangent And there's one that I didn't show very clearly here, but it's this point right here, and this is 1, and that's when x is pi by 4. Then the tangent has a value of 1. And similarly, if you went to, not that we want to get into it, but 3/4 pi, you'd be at -1. But I'm not going to worry about that. But this is a good one to know, this little guy here. Okay, that's where I'm going to stop with our look at graphing of trig functions for now.